Yeah. So one of those are going to get abstracted by the amine, right? Those H's.
One of the electron pairs or the caps? I don't know.
One of the electron pairs. These here. Whichever one of these is going to go like this. I mean,
it loses a hydrogen.
The arrow will eventually do that, but this has to go somewhere.
Yeah, to the amine.
Somebody has to take this.
Right.
Who's going to take this?
The amine. That you
The amine.
deprotonated from the water.
Somewhere. Okay? One of these amines is going to take it. There you go. It leaves.
And then that lone pair is going to go on the nitrogen.
Yes. And then that electron pair from that double bond, like she was saying, is going to go in there, and this nitrogen is going to get an electron pair back.
Yeah.
And what you formed is this.
Mm-hmm.
Yes? Yes or no?
Yeah.
Should have done it like this one.
Why this one got less?
Yeah?
Got less memory on it?
No, no, no.
Oh, okay.
What? A memory card for every class? You're right. You were gonna buy them for me? What?
You get it on Amazon, it's cheap.
Can I get it on Amazon? If you get it too, it's cheap too. It's cheaper for me. No, don't worry. It's speed 10. If you're interested.
I don't know what that means, okay.
You don't know what that means? Don't worry, okay? I got plenty of them. I got 7 in there.
Speed?
No, not 7 speed. I got 7. 7 of these things in there, man.
Just like the broad.
Yes, I take a lot of pictures of flowers on the weekends and stuff.
You're a gardener?
Butterflies and all that.
Like the cute neighbor next door.
The cute neighbor next
The
door.
cute neighbor next door.
What happened? Why doesn't the water get? Because this is a little bit more basic than water. If you do it with water on the test, I don't really care. But you know, you form one water molecule, and there is lots of those. So
you said you don't mind, like how we show which step comes first when
I do like this.
yeah, which step comes first? If you get this deprotonated versus that protonated after, I don't know. Like deprotonations of the amine or protonation of the alcohol. Doesn't matter. Okay, what else, guys? Is that good?
Yep.
I think that's the end of this chapter, yes?
Yeah.
That's the end of this chapter. You are going to have absolutely every single reaction on the test. Some are going to be very simple, and some of them are going to be a little bit hard to see. Like this one, they're a little bit hard to see to you. Like this one, when you treat this with MCPBA, that was hard for you to see, yes? No, it wasn't? Okay, but for some of you it is. Okay? You are going to have, let's say you have this.
Yeah, that's the one. That's the one. It's just how to draw it sometimes. You like, man, think about it. Okay, how many carbons? That's what you use. Yeah.
See see like how it goes from that to like.
Something like that. Where did that come from?
Exactly. I don't know where it goes.
Let's say it's a 5-member ring, okay? Besides the point, where did that come from?
Set out. Carbonyl.
When you look at it, you go, what is this? A sorrow. The mask of sorrow, yes? Yeah, and you look here, and it has an oxygen with an R group and an oxygen with an R group on the same carbon. This is an acetal. Where did the acetal come from? That is an intramolecular cyclization, yes? It is an intramolecular. Where is the carbonyl at? The carbonyl is here. And what is that? So I cut it here, and I cut it here. So the carbonyl is here, and what is that? That's an OH and another OH. Okay? This is stuff you have to get used to. I can't do many of those problems because we'll never finish the semester. Okay? Yes?
Mm-hmm.
You're going to have intramolecular stuff on the test. Because last test, you all got that problem right of an intramolecular Friedel-Crafts. Remember? You all got it right. I don't know. I thought it was really difficult. But Mitch was like, damn, class is good. Got that question right, everybody. And I'm like, of course, man. Okay. It's over, okay? You're going to have all of these reactions. You're going to have synthetic stuff using some of the reactions from organic 1. Okay? Sorry. Like I expect you to know oxidation and reduction from organic 1. You had it here too again. Not oxidation, but you had reduction with what? Lithium aluminum. Lithium aluminum hydride, yes?
Yeah.
And now you know that this hydride is a
Nucleophile.
nucleophile. The nucleophile is H-. Carboxylic acids. Which mechanisms from aldehyde and ketones do you want on the test? You want acetal?
Yeah, of course.
All right, you got it. You want enamine?
Yeah.
Those are the harder ones.
Yeah, that's good.
And then I'll give you some easy ones, like Davidic or Grignard or hydride. They're not as easy as they were shown there, but kind of the same. Yes? So 5 mechanisms from aldehydes and ketones. Is that good for you, Karen? So carboxylic acids. Everybody in here already know how a carboxylic acid looks like, yes? This is a carboxylic acid. Some of these common names are allowed by UPAC nomenclature. Okay? Now the purpose of me here is not to teach you naming. I don't really know that much about naming, but that is the ending of it. When we had alkenes, the ending was ene, yes. When we had alkynes, the ending was ine. When we had alcohols, the naming was all at the end. And now these are oic acid. So, 1 and 2 carbons, that is what parent chain? Ethane, yes? So the name of this is ethanoic acid. Yes? Ethanoic acid. That's cake, yes? Now other professors are better at naming than I am. I am about the worst at naming in the world. That is a derivative of this carboxylic acid, yes? A proton has been pulled off with what? What was it pulled off? With a base, yes? With a base. A proton was pulled off with a base, and now this has a negative charge. Okay? Now, if you do that, and there is, let's say you did this with sodium hydroxide, yes? You formed water and this sodium plus. The positive and the negative together. The name of this will be the name of the metal in full. plus the name of whatever polyatomic ion you have, right? Or whatever the name of the rest of it is. Now, this comes from where? Ethanoic acid, yes? The ending for a negatively charged conjugate base of the carboxylic acid will end in ate. So this is called the sodium ethanoate. Sodium ethanoate, yes? Now, of course, there is a common name that is accepted, and the common name for this is acetic acid, yes? Acetic acid. So, common name for this is acetate. So, this sodium acetate, okay? But as far as the naming is concerned, so let's, what's the name of this? I want you to give me the common name. The common name of this is benzoic acid, yes? Common name.
Sodium.
Benzoic acid. At the end, it ends in oic acid, anyway. And this is sodium
Benzoic acid.
Professor, so the derivatives are the conjugate bases with something else like.
That's one of them. There's esters, there's
Oh.
many things.
So it's not just that.
No, it's not. It's just the one that is negatively charged. Now, carboxylic acids are basic, yes? Or acidic? Acidic or basic?
Acidic.
They are acidic? That's why they are called?
Carboxylic acid.
Outstanding.
Can you put that question on the test?
When is the test? Next week?
What?
When next week?
No.
You got these, shouldn't worry about.
Guys, I don't know the test when it's going to be. It's going to be after I'm finished with the carboxylic acids. And my guess is that the test is going to be some serious business. My guess. So, I'm going to give you part of the test on one day. If you can't finish the whole entire test, then I'll give you the other part another day. You won't see that other part. But there's no way I'm going to dilute it. You understand?
Uh-huh.
I'm sorry. But I am the easiest professor in school, so you have heard about that before. What's the name of this? Because I don't think we've ever done a name like this before. We want to name it based on the carboxylic acid. Okay? And what type of group is this?
Methyl.
This is a
Methyl group. Yeah.
And this group is a?
Alcohol.
It's not an alcohol. It is an alcohol. You're right, it is an alcohol. But we're not going to name it as an alcohol. Whenever you see an OH and you don't want to name it as an alcohol, it is named hydroxy. Okay? So hydroxy is an OH. Hydroxide is OH minus. Okay? So that's hydroxy. So name it based on that hydroxy as if it were regular. Everyone signed the attendance?
No.
Pass it back. So what's the name of this? Longest chain is?
Five.
Five.
It's
Five.
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 This look like a methyl group, yes? 1, 2, 3, 4, 5. So it is 5. So 1, 2, 3, 4. No, I'm counting just how long the chain is. Yes. You do start here. Okay. This is carbon 1, 2, 3, 4, and 5. So on carbon 4, I have a 4 hydroxy pentanoic acid. Or hydroxypentanoic acid.
What about its derivative? Do you do a derivative for that one? Or it's complicated for you?
Same as pentanoate, sodium pentanoate, 4 hydroxy. Which one is more acidic, this one or this one? Is this or is that hydrogen more acidic?
The hydrogen to the right because
This
of the
is more
inductive
acidic. Why
effect.
is this more acidic?
Because of the inductive effect.
Because the CH3 will become more.
That's because
This one is more acidic because of something called resonance stabilize, yes?
okay. Yeah.
It is, this oxygen here is withdrawing electron density from this bond, making it more acidic. That's right. But this is resonance stabilized, okay? So, stuff we learned in 1046, yes? Carboxylic acids make hydrogen bonds, yes? Yes or no? They make hydrogen bonds. The pKa of this is more or less 4.8. You do not have to memorize, write this down, because you will be confused. You do not have to memorize any of the pKa's, okay? You do have to have an idea of which one is more acidic than the other. Like for example, which one is more acidic, carboxylic acid or an alcohol?
Carboxylic acid.
How much is a carboxylic acid? What's the pKa of carboxylic acid more or less?
Yes.
You can say the pKa of a carboxylic acid might be 4.
Mm-hmm.
You can say it might be 3, might be 2, might be 1, might be -1. Okay? The pKa, and they are like that. Now the pKa of an alcohol, it's more or less around what number? 15, 16,
16, yeah.
okay? Big difference, yes? The pKa of phenol is around what number?
15, 16? Oh no.
pKa of this is around what number? It is not 16, okay? That is more acidic because of
The ring.
the ring is stabilizing that negative charge that is formed there. Okay, basically a ring is capable of stabilizing a positive charge and a negative charge. Okay? So this is more or less 9, pKa 9. What I care about is that if I do this, and I put hydrogens and 1 chlorine on that, the pKa, you expect the pKa to do
Go
what?
lower.
To go lower.
Yeah.
Because this is more acidic
Acidic.
because of
The chlorine.
the chlorine here. The chlorine is withdrawing electron density that way, which is withdrawing it from here, and eventually from this oxygen-hydrogen bond. Yes?
Mm-hmm.
Because it's separating electron density that way, that's making this more what? More
Acidic.
positive, yes? And of course, if I put another one,
It's even more acidic.
that's more acidic. And even more acidic than that is
Another one.
how acidic is this?
Like
This is very
negative?
acidic.
Does it get to the negative?
It's almost acidic as a strong acid. Okay? If it's fluor, yes. Fluor is in the negative region.
Okay.
So this is very acidic. Now you expect the pKa's to drop. The
Yes.
drop is not something you have to memorize. I don't care what the numbers are, as long as you know that the chloro is more acidic than the non-chloro. Okay? What do you expect to be more acidic? What do you expect to be more acidic?
The one on the right, because of the ring.
The one on the right is more acidic
Yeah.
because of the ring.
Ring.
Okay? It is more acidic. Which one is more acidic of those two?
It's the same.
Which one is more acidic?
The one on
The-
the right, right on the right.
Okay, write this down. This is for para-substituted benzoic acids.
For parasubstitute.
Para-substituted benzoic acids. Electron withdrawing in the para-substitution make the acid more, or make the acid stronger. What? Electron withdrawing groups in the para position make the benzoic acid more acidic. So, which one is more acidic? This or this one?
One to the right.
This one is more acidic. Anything you put here that is electron withdrawing, and you already know a few of them from electrophilic aromatic substitution, yes? In fact, you know most of them. This is more acidic than that. Which one is more acidic?
Methyl oxide.
Oxygen and
And
a
the methyl.
methoxy.
The one in
What is that? H?
Which one?
the one in the middle.
The nitro or the methoxy?
Nitro.
Nitro is more acidic. This is less acidic
Than
than
that.
that.
Okay.
Okay?
Wait, what?
Because
Is that H2O?
Wait, why is
Is that H2O, Professor?
No, that's.
Is that H2O?
why is the methyl?
this is ME.
CH3.
Okay, you don't like this ME, do you?
CH3.
Why is that methyl less acidic?
You can't see?
Why is the third one less acidic than that?
Okay, I told you that if you place electron
Withdrawing.
groups on the benzene ring, it will make this more acidic. If you place electron
Donating.
group,
It's gonna make it less acidic.
less acidic. And this is the standard, yes? This is like
Yeah.
in the middle.
Uh-huh.
Electron withdrawing, more acidic. Electron releasing, less acidic.
That makes sense.
Yes? Which of those two is more acidic?
The one on the left.
Yeah.
The one on
On
the
the
left
left.
is more acidic. These methyl groups are considered what double groups?
Releasing.
Pushing or electron releasing, so that's making this less basic.
Right.
More acidic, less acidic. What's happening to these pens?
Garbage.
Yeah, let's see this one.
Oh, that one's nice.
Yeah. So arrange those in order of acidity. Which one is more acidic?
The one on the top left.
The one on the
Top
top
left, yeah. Then the one on the
is
bottom
more
of that.
acidic because?
Because of the chlorine is closer to the.
That's right, the chlorine is
closer
closest
to
to the
the
carbonyl.
Yeah.
And then this
This
one is
one?
2 away from it.
Uh-huh.
And
then
this
that's
one is
3.
3. They still have an effect, even if it's over a distance. Okay?
Conductor.
Yeah. What do you have?
Because that chlorine is more closer to that group. Yeah, it's because of the inductive effect.
These are carboxylic acids. They are dicarboxylic acids. Oxalic acid. You ever use this in 1040, 1046? Zucchini over there? Zucchini, yeah. Yeah, zucchini. We use oxalic acid in 1045, yes? That's oxalic acid. Is a dicarboxylic acid. And the order is oxalic, malonic, succinic.
Succinic.
This is not zucchini. Succinic. So, oxalic acid, malonic acid, and succinic acid.
Succinic.
And the difference between them is that these have a carbon in between. So, when you have the both carboxylic acid with no carbons in between, it's called oxalic. It has a carbon in between, it's called
Malonic.
malonic. And if it has 2 carbons in between,
Zucchini.
That's already stuck in my head.
okay, let's. Which one? You guys want another quiz on Monday?
What? Wait,
You want a quiz on Monday?
Yeah.
Yes.
Yes.
Yeah, we want it on
Or
Monday.
Tuesday.
Extra credit? Yeah, we want it on Monday. Even on Sunday, we'll be back. Extra credit.
While we at church. Come give it to the preacher.
You gotta go to church?
No, I said we could do it while we at church. Give it to the
Actually, I
preacher.
don't know. I might have a heart attack that night. I know. It's a miracle. Like, oh, Jesus. Help.
Okay. So let's say Okay, let's say we have this, guys. What's that? What's that called?
Cyanide. Sayonara. Sayonara.
Cyanide? No, cyanide is this, my friends. Cyanide, potassium cyanide, sodium cyanide, hydrogen cyanide. This cyanide. That's not cyanide. That's called a nitrile.
Nitrile. Nitrite.
That's called a nitrile. Nitrile, yes?
Yes.
So this is nitrile, and we can get this there from doing what? From doing some type of nucleophilic substitution, yes?
Yes.
Nucleophilic substitution. Maybe SN1, SN2. How many others do you know?
Just 1 and 2.
1 and 2. So after this is there, if I treat it with H3O+, so water and an acid, what do you get? How do you know this is a carboxylic acid? Because this is a carboxylic acid chapter?
Because it's an aldehyde.
Yeah, it's the last, like the last thing in that. Yeah.
Because we have already done this, okay?
Yeah.
That's how you know.
Yeah.
I think we even did it in 1045, right?
Yeah. No.
I didn't think
1045.
organic
Yeah, organic one.
Yeah.
You what?
I said I thought it's because we have easiest teacher in the world.
You do have the easiest teacher in the world. You would have taken this class with somebody else, you would have been challenged for real. With me, you're not challenging. This class is not challenging at all. No, Karen does sarcasm. I don't do sarcasm. I do evil things. Okay? So let's say so give me the nitrile from which that came from.
This came from. I believe this. Right?
So it came from stage 3.
Guys, give me the nitrile from
Which
which
it
that
came
came from. Write it down on your paper. Which is the reaction that gave you that from a nitrile?
Wait, you have extra juice?
I have some
So we have the lead.
lead.
Which nitrile did this come from? What?
I don't even have any lead.
Like this?
No. One more.
Oh, another card.
Yeah.
Okay, so you count. How many carbons after this ring here? 1 and 2. The nitrile will begin here. It will be a triple bond to this, yes?
Yeah.
And yes?
Yeah.
I asked which nitrile did this come from? And this nitrile came from which alkyl halide? What? That one? Not that one, yes? This one? Right? You mean same thing. That one, it came from that one?
Yeah, that one.
What was the difference between
Just that and
Two carbons.
Two carbons versus one.
What do you mean, what's the difference? How can you be asking me at this stage of this game?
Oh, no. I didn't say
Yeah,
that.
that's
Now
only
I-
one.
Which alkyl halide did that
first
nitrile
one.
come from?
The first one.
Bottom.
The second. Yeah, the top one.
Right.
Well, didn't we say it was
With the two carbons.
Okay?
Okay, you mean that our...
I mean, the CN does have a carbon, yes, but it adds to the chain.
Oh, yeah, the
So,
one on the bottom.
If you have 1 and 2 carbons here, you'll be adding another one, that would be 3 carbons.
Yeah.
So, it was added to this one. This one has 1 carbon, plus the carbon from CN, which will begin here, will be CN here. So, it came from this one, not this one. Okay? Yes?
Yeah.
We have a triple bond and ozonolysis. What else do I need on ozonolysis?
DMS, right?
Is it DMS? No, don't you need like a zinc or something? You need a zinc like
What?
a metal. Zinc and HCl.
Don't you need DMS?
You could, it could be.
Tell me.
So, H plus? All right. Ozonolysis, there's slightly different things for ozonolysis. What do you get from there? You get 2 carboxylic acids, yes?
Uh-huh.
Let's say this is R1 and this is R2. You get R1 plus R2. So a way of making carboxylic acid is ozonolysis of a triple bond. How else can I make another carboxylic acid? I can have something like this, and I can treat this with what? I can treat it with KMNO4. What else?
CR, NaCr.
And chromic acid, yes?
Yeah, chromic acid.
So KMNO4 or
Shoot, man.
chromic acid, okay? This chromic acid could be this H2Cl2 or 7, something like that.
That's what you need.
That's what?
That's what
The 7 is for what?
it's for sodium, it's for sodium, the Na2. Isn't that Jones reagent?
Sodium chromate and sulfuric acid, yes? It doesn't matter, chromic acid. And this is going to give us, these are reactions from what class, guys?
Orgo 1.
1045, yeah. What else? What else would give you carboxylic acid? Let's say, yeah, let's do that. Let's say we have this.
PCC is
Carboxylic
aldehyde.
acid.
I use PCC as a,
No, it's aldehyde.
what
Yeah.
can I use? What?
Jones reagent.
You have aluminum.
Chromic acid. I can use chromic acid. Okay. Same thing as the one on the top, okay? Chromic acid, yeah, chromic acid. Same as the top.
Yeah.
That makes me ketone.
Can we get one from Grignard? So,
For pinnacle? No.
let's say, we have this. Let's say we have this. What is this?
Grignard.
Nucleophile.
Nucleophile, yeah. Nucleophile, yeah.
What type of charge would that have?
Negative.
Negative charge? So, in the first step you do that, and in the second step you do this. Why don't you try to draw a mechanism for that?
Okay.
That is, the COO is what? Carbon dioxide, yes? That's CO2. Look, let's do this. Let's do this like this. Add H plus here.
So hell no. Why look at this?
Okay, guys. Grignard with CO2 gives you carboxylic acid, yes? This is a source of
Yeah, that's right.
negatively charged. This is a nucleophile. And you have, yes?
Yeah.
And what happens is that this
But it's
is
still partial.
electron deficient, yes?
Yeah.
This is going to get
Yeah, it's still attacked.
attacked by that.
Uh-huh.
Lone pairs
The
are
pair
going to
goes
go
up. Yeah.
that way. And what you are going to get from there is this
Double bond to the O with a negative oxygen and the CH3.
with the oxygen with a negative charge.
Yeah.
I did it the other way, right? I did this way.
Yeah.
The
And then-
oxygen with a negative charge.
Just get pronated by water,
Now,
right?
this is the reason why you need water or you need
H
let's
plus.
say H plus,
Okay.
okay? Because it will be pronated, so we're gonna say a source of protons, yes? Source of protons will give you carboxylic acid. I want you to make that over there in two different ways. I want you to come up with 2 different ways of making this. 2 different synthetic pathways.
Okay. See what we got.
You want hints or no?
No, no,
You
no.
got it.
We got it.
Yeah, don't say nothing. Don't say nothing.
You got it. La Vista, what's the deal, man? Did you urinate in some type of bottle back there or something? I haven't gone to the bathroom today, man.
He's not so sure anymore.
No, okay.
Ready?
No, no, no. Wait, no.
I did 2 already, and I'm trying to find it.
You want hints or no?
No, 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 no.
He
You can
doesn't
use
want.
one of the further frames.
That's an easy one, okay? If you can't do this
Can we
one.
save your hints for the test? Just saying.
Okay, look.
Yeah.
This next test is gonna be very hard. It is. But you're gonna have extra credit because LeBron is planning to lose.
I better pray, man.
How many points per game?
I'm gonna give you the difference between the points. You know? If they win, if Golden State wins today by 20 points, I'm giving you 20 points.
Oh, okay.
If they lose, I'm taking them off.
What?
Okay, test grade.
No.
Oh, that's the way it works.
I would take that chance.
Is that the way it works?
They're gonna win today.
I got food.
Golden State's gonna win today. What do
They
you mean?
gassed out, man. They kept gassed out.
White people hate LeBron, man. I don't get it. I hate him because I'm a player hater, you know? I hate everybody that is good. Because, you know, that's how it is. Got a big truck.
Ain't nobody like Michael Jordan while he was playing.
Except me. I love
I
Michael
love
Jordan.
him.
Nah, but if
That's
that
why I
wasn't
don't like
your
anybody
team,
else.
But if that wasn't your team at the time, like if you like Phoenix Suns or New York or even Miami, you didn't like Jordan. You didn't like the Bulls.
You're right.
So I like him now.
I like Michael Jordan from when I was a kid in Cuba, man.
I don't like Derrick Rose, so that's why I don't like the Bulls.
Because he made that movie, Bugs Bunny, yeah?
That's how you know.
That's such a, you know, he wanted to do it with LeBron James. Yeah.
And Shaquille O'Neal made a movie too. I like
Shazam!
I never saw that movie.
I love that movie too. That movie's
Have you seen
amazing.
the Justin Bieber Rose?
It's gin, yes?
Oh, yeah.
I'm gin. Alright. So, what are we gonna do here?
Can we do Frito crab?
Okay, you can do Frito crabs.
Yep.
What is it called? Acylation?
With
With what?
CHCl.
Which one?
Yeah, Louis Sassy. Seal with the color.
CL?
Like a living group from the camera.
Come on, guys. tell me
ALCL.
ALCL3?
Yes.
Okay.
And then you put a methyl group on it.
Oh, you put it on the top.
And then you do it, and then you do KMNO4.
Very nice. That's CH3 and that's KMNO4. Yes?
Yes.
Okay. Or?
Or chromic acid.
Chromic acid.
KMNO4 chromic acid. How about this? Would that work? I don't have methyl. I gotta put this one on it. Because in the lab, this is all I have. I ran out of that.
So now you have 2 carbons.
So then you have 2 carbons. 2 carbons.
It's still gonna give
It's still gonna give you-
It's still gonna give
give
you.
you the same thing, no matter how long
It's still gonna give you.
I can still do it, right?
Yeah.
KMNO4. Yes? And both of these are the carboxylic acid. Benzoic acid.
However, why can't you do acylation? Wouldn't that give you a carbon and double bond O?
What?
Why can't you do acylation for oxidation?
Because you can't do it with the carbonyl OH there. You could do an acylation, yeah. But then you'd have to oxidize it still, so you'd be wasting a step. You know. What else? Yeah.
You probably do the same one.
That was where I was going.
That's how
It's the other way, yes? You needed 2 ways. That's not 2 ways, that's the same way.
Right.
Okay? So
That would be really good.
I can have here BR2, and most of the time we don't use aluminum for BR. Okay, you can use either one of them, okay? Let's use FeBr3, yes? And this is gonna be what? Electrophilic aromatic,
Substitution.
okay? Put a bromine there, and then I'm going to make a Grignard for this business.
Yeah.
What do I add to make the Grignard?
CH3.
MG what? MgCH3.
CH3 MGBR. CH3 MGBR.
What?
CH3 MGBR. CH3? Yeah. MGBR.
No, that you're making the greener.
Guys, what the deal is? I'm making a Grignard. This is active halide, yes?
Yeah.
Aromatic, but you can still make it, yes?
Yeah.
So this is going to give you, I'm making the, is this
Okay.
conditions to make Grignard, yes or no?
Yeah.
With some solvent, yes? With some solvent, which, you know, whatever solvent, ether or,
MGBR.
and now this is going to look like this.
MGBR.
MGBR. Yeah.
MGBR,
Yeah.
okay? MGBR, that's a Grignard, it works this way. And then what do I add to this?
CO2, right?
CO2 and H2O and H plus, yes?
Yeah.
And this is going to give you,
That's a good one.
you like this one, don't you?
Yeah.
Yes.
It's more shiny.
Professor,
Instead of using VR2 and E, could I have done MDS, but that would have worked too, and then just do the same steps with Grignard and Substituent?
No. Not MDS on here, no. Has to be MDS. If it had a methyl group, you can do MDS.
Oh, it has to have a method.
Yeah, it's allylic bromination.
Professor, that one there is MG.
Professor Garcia.
CHPVR, right?
What? MG? Yeah, BR, yeah.
Is that MG CHPVR?
Where?
Where you're working like these?
Here?
No, there. On the arrow.
Here?
Yes.
No, MG?
I have a question. Is it possible, like, straight off the bat, you can start with Grignard?
Oh, it's right.
Like the CH3 MGBR? That won't work? Just to put a methyl there and just,
Professor,
that won't work?
You can't do Grignard on that one. It's not gonna do
Professor,
on the benzene ring.
see, yeah, that's what I was.
Yeah, but that's not gonna, it's not gonna work on that.
Oh, no.
Okay? Guys, where are you guys going? We treat this with thionyl chloride, yes?
CO3. CO2, sorry.
Thionyl chloride. And when you treat this with thionyl chloride, you have seen this reaction before
Yeah.
from General Chemistry 1, yes?
From organic one. No. Organic one.
From one of the alcohols, and what did it give you?
It adds chlorine to the
And
orange.
PBr3, it gave you from an alcohol, it also gave you bromine, yes? So this is going to give you chlorine. It's gonna replace the OH, like it did before. It's gonna replace the OH. And this reaction is, what type of reaction is this?
Substitution.
It's substitution, very nice. But, and this is a acyl chloride. Now this acyl chloride does a lot of things. Okay, like a carboxylic acid can almost do anything, okay? But if you have this acyl chloride and you add, let's say, some type of alcohol to it, what is going to happen?
Attack.
When this was a ketone, did this alcohol attack this carbonyl? Yes or no? If it were a ketone, would the alcohol attack the carbonyl? In the presence of an acid? Hello?
Yeah.
Yes,
Yes, it would.
yes.
What would it form?
The OH with the O negative.
Let's say I had excess of it, what would it form? Acetal, yes?
Acetal, that's the
Acetal.
acetal.
Here, it is still going to attack it, but now I have a leaving group, okay? I have a leaving group. The leaving group before had to be water, and it happened again, right? I have a leaving group now, and what is going to form is an ester. Okay? Yes?
Yeah.
And if what you have is this, what is it going to form? Amide. I guess you want the names here, ester, amide, or amide, whatever you want to call it. How about if there's water in here? If I add water to that, what would it form?
We'll just hydrate them.
Let's say I have this. What is it going to be? Carboxylic acid, yeah. Now, the side product to all of these is what? No, we do care for this one, okay? We don't care all the time, but once in a while we got to care. Side product to this, and the reason why we have to care about this is because the side product to this will destroy things. Okay? The side product to this is that H and that Cl.
Oh, okay.
Plus HCl and H and Cl plus HCl. And the HCl can do weird things. Okay? The HCl can do acetal formation, yes or no? Like it did before? So what we want to do is we want to add something that will take this away so the HCl doesn't protonate this and makes trouble. Yes? Most of the time what we add to take this out is pyridine.
With the nitrogen. Yeah.
That is what you add.
Pyridine after or before?
During, I mean,
During?
yeah, after,
So
before.
will some of the HCl still react with the ester or the amide?
No, because you're adding this, because you're adding this at the beginning of the reaction, right? So once you form this, it will form pyridinium chloride. It will form, this will be H plus now on this nitrogen, right? And the Cl minus. Okay, we'll talk more about this next class, okay? I think we're gonna finish this chapter soon, right? So you make plans. The next week is not the test, but the week after that, you have a test. The mother of all exams.